So today we're going to be focusing on Chapter 7, Section 2, multiplying powers with the same base. So the first thing we're going to do is a review on evaluating an exponential expression. We started to cover this topic on Friday, but we're just going to go over it again. So let's evaluate the expression for a is equal to -4, b is equal to 3, and c is equal to 2. That's what, when I tell you a is equal to this, b is equal to this, and c is equal to that, what you're going to be doing is you're going to end up substituting those back into the problem. That's just what you're evaluating those numbers for. So your problem is a to the 0, c to the 4th, all times 9. So what your first step, I just rewrote the problem, a or 9 times a to the 0 times c to the 4th. My first step that I'm going to go ahead and do is plug in -4 in for a because I'm told a is equal to -4. I'm going to plug 2 in for c because up here I was told c is equal to 2. Now I go ahead. Some of you might ask me, well, shouldn't I do 9 times -4 times 2? The first thing, remember, PEMDAS, what you have to do is you have to do the exponents first. And as a reminder, any number to the 0 power gives you 1. So -4 to the 0 gives me 1. And 2 to the 4th power is multiplying 2 by itself 4 times. So 2 times 2 gives us 4, times 2 gives us 8, times another 2 gives us 16. So you're left with 9 times 1 times 16. Put those all in your calculator, and your final answer is 144. So same thing. Let's evaluate the expression for a is equal to -4, b is equal to 3, and c is equal to 2. I give you 4 a squared, b to the -2, c cubed. I just rewrote the problem. Remember, when we do this, we don't like to have negative exponents. As a reminder, when you have a negative exponent, what you got to do is if it's in the top, so if it's in the numerator, if there's no fraction, what you got to do is you got to make it into a fraction now. So the first thing you got to do is get rid of this b to the -2. So you automatically now make a fraction and drop it into the denominator. When you do that, it now becomes a +2. And just say, for instance, this was the original problem I had given you, but this was now a -2. To get rid of the -2 in the denominator, you bring it up into the numerator and make it positive. So, but that's not what we're doing. So we're going to have 4 times a squared times c cubed, all divided by b squared. Your next step would now be to fill in for a, b, and c. A is equal to -4, c is equal to 2, and b is equal to 3. So we went ahead and did that, and now remember, we don't do 4 times -4 times 2. Your first step would be -4 squared, 2 cubed, all divided by 3 squared. Remember, any negative number to an even exponent is going to be positive, and any negative number to an odd exponent will be negative. So -4 squared gives you 16, 2 cubed gives you 8, and 3 squared gives you 9. So now you're left with 4 times 16 times 8, all divided by 9. As a reminder, we're straight up multiplying directly across. You're not doing the distribution proper. You're not doing 4 times 16 and then 4 times 8. It's 4 times 16 and then that answer times 8. 4 times 16 times 8 gives us 512, and that's over 9. And remember, if we put that in our calculator, we would do 512 divided by 9, and then you'd get a decimal. And if we wanted to see if we could simplify that fraction, what you would then hit would be math and then the enter button twice. And it doesn't simplify and down any further. It stays as 512 divided by 9. So now we're going to start with Chapter 7, Section 2, multiplying powers with the same base. We're on page 425. When multiplying numbers with the same base, you're going to add the exponents. So our rule for that is, if we have a to the m times a to the n, now our bases are the same because it's the letter a, you're going to add the exponents. So it would be a to the m plus n power. Let's demonstrate that with some numbers. 3 to the 4th times 3 to the 7th is the same as doing 3 to the 4 plus 7. Now we add these exponents. 4 plus 7 gives us 11, so your answer would be 3 to the 11th power. What is the expression written using each base only once? So if you get 12 to the 4th times 12 to the 3rd, we want to rewrite it using each base. So we don't want to kind of see that it's 12 to the 4th times 12 to the 3rd. How can we make it nicer? How can we make it a little simplified to look at? Well, what you're going to do is you're going to add the 4 plus 3 because they're the same base. They're both 12, so now we can add these exponents together. So 4 plus 3 gives us 7, so your final answer when we rewrite the expression using the base once would be 12 to the 7th power. Let's try this one. What is the expression written using each base only once? So now you get negative 5 to the negative 2 power times negative 5 to the 7th power. Some of you might say, oh, there's a negative exponent. We can't have that. We need to simplify that first. My suggestion is worry about doing that later. Don't worry about doing that right away, right now. Because to rewrite it using each base only once, negative 5 is the same base in both. So what you would do now is negative 5 to the negative 2 plus 7 power. Negative 2 plus 7 gives us 5. So your final answer is negative 5 to the 5th power. That's why I told you don't worry about switching it. Don't worry about getting rid of this negative just yet. We're going to go over that probably tomorrow. But when we do that, all we have to do is when we're multiplying, you just do negative 2 plus 7. That gives us a positive 5. Now we're going to do multiplying powers in algebraic expression. There's going to be a couple rules you have to follow. Your first thing, you're going to multiply all the numbers together. Second, you're going to add the exponents of the powers with the same base. So like in this example over here, how we have negative 5 and negative 5, they're the same base. What wouldn't be the same base is if I gave you something like x squared and y squared. It's kind of, think about like when we did combining like terms, you can only combine x's with x's and y's with y's and so on. Same thing here. Exponents of the same powers with the same base, or add the exponents of the powers with the same base. So same bases, you can only add exponents then. And then if necessary, meaning there's a negative exponent, you're going to simplify using positive exponents only. And that's what I went over with you guys when I told you we don't like that negative if the negative's in the top, or if there's a fraction. So if it's in the numerator, or if there's no fraction and it's just a negative exponent, automatically put that negative exponent down into the denominator and it becomes positive. And then if it was already a fraction and the negative exponent was in the denominator, bring it up to the top into the numerator and make it positive. So you kind of just switch where they are. So what is the simplified form of the following expression? 4z to the 5th times 9z to the negative 12. Well, first thing would be to multiply the 4 times the 9, and then these are the same bases. It's z and z, so we could do z to the 5th times z to the minus 12. Well, you can multiply 4 times 9 and we get 36. Now these are the same base. They're both z's, so now we can add them. So we could do z to the 5 plus a negative 12. So we rewrite this, bring everything down, 36z, and then 5 plus negative 12 gives us negative 7. So your answer is 36z to the negative 7. But remember, we don't like this negative 7 up here. So where do we got to do with it? We got to bring that whole entire z to the minus 7 down into the denominator. When we do that, it now becomes positive. So your final answer would be 36 over z to the 7th power. Let's try this one. What is the simplified form of the following expression? Negative 4c to the 3rd times 7d squared times 2c to the minus 2. It's okay. First thing I like to do is I like to pull all those numbers out and pull all those numbers out. So we have negative 4 times 7 times 2. And then what I like to do next is I like to group all of the same variables together. So we have c to the 3rd times c to the minus 2 times d squared. Remember, multiplication is commutative, so you can kind of switch the order up and it won't have an effect. You could do 2 times 3. You're going to get the same answer if you do 3 times 2. So the first thing I'm going to do is I'm going to multiply 4 times 7 times 2, and I get negative 56. And then my next thing, remember, these are the same base, so now we can add these exponents. C to the 3 plus negative 2, and then d squared. Can't add anything, can't do anything with this d squared because there's no other d there. So when we do 3 plus negative 2, we get 1. So your final answer is negative 56 c to the 1st d squared. So what I'm going to try to do every day for you guys is I'm going to showcase a different pet of the day. So today's pet of the day, once again, is going to be Ginger. Ginger's 5 years old. She loves to eat her milk bones as her little snack. She loves to go for walks on the beach. She also loves to run on the beach. Every night around 7 o'clock, she knows when it's time for her to go out for a little walk. She will go sit by the door, and if we're not there, she'll just start barking for us to come take her out because she knows it's 7 o'clock. It's time for her walk. And then usually after her walk, she gets like a second wind of energy. She starts running all over the place and acting crazy, and then she likes to play for a half hour, and then 8 o'clock comes and it's bedtime. So what I'm going to have you guys do is by Friday, April 3rd, I want you guys to send me a picture of your pet, and I want you to tell me a little bit about your pet. Tell me how old your pet is. Tell me your pet's name, what they like to do, something, if your pet does something funky or unique. So that will count as some extra credit for you guys. So I need that by Friday, April 3rd. And you're going to send it to my email. Your homework is on Plus Portals. And then be sure once you complete it to send me it in an email.